there we go. Thank you. I appreciate it. Okay, here are the notes from 6.2. And 6.2 has to do with the law of cosines. As I told you last week, there are two laws you need to know. The law of sines, which we used in today's warm-up, and you guys seem to do fine, and the law of cosines, which is his cousin. And they're used for the same purpose, but in different ways. Because of time, I am going to skip the derivation and just go straight to the formula. Here it is. The law of cosines is this. It doesn't matter which way you write it. It doesn't matter which letters you pick. It's going to be the same thing. But what I want you to notice is that the law of cosines is really a modified Pythagorean theorem. I'm going to write that down. Modified Pythagorean theorem. What do I mean by that? What I mean is that way back in 8th grade, you learned the Pythagorean theorem. And you learned a Pythagorean theorem, and it kind of looked like this. You know, you had a right triangle, and you got this measurement, which was 6, and this measurement, which was 4. And then the question was, what is the measure of side C, right? And you can use a Pythagorean theorem for that. But this had to be a right angle. Well, now we're going to do the law of cosines, and the law of cosines basically says, all right, if this is 4, and this is 6, and this is even 83 degrees, you can still find the length of side C. We just need to modify the Pythagorean theorem a little bit. And that's what this does. Take a look at it, especially the last rendition. You'll recognize that one very well. It says C squared equals A squared plus B squared. That's a Pythagorean theorem. However, to adjust for any angle, and not just 90 degrees, we are then going to add minus 2AB times the cosine of C. Notice that the letter you start with, C, is the letter you end with, C. In all the cases, A, B, B, and so on. Let me give an example of how this works, just so you can see it in action and you understand what all these letters mean. So let's take a look at this triangle down here. This is side A. This is side C. And this one here is side B. Agreed? What we're going to do is we're going to solve the triangle. In other words, we need to find all the side measures and all of the angle measures. We'll start with the side measure. Notice that what we have here is a side, angle, side situation. Side, angle, side. So I can find the area easily. However, think about it. If I said to you, using the law of sines, find the perimeter, could you do it? If I said, find the perimeter of this, using the law of sines, here's what you'd have to do. You'd be like, all right, the sine of 39 over blank, equals the sine of blank over 21. You there have too many blanks. You cannot use the law of sines with an SAS situation, but you can use a law of cosines, which is what we're about to do. So here we go. Because we're looking for A, let's go ahead and use this version of it, but it doesn't really matter. So we're going to write A squared. I'm going to go ahead and write it down. It looks really long, but it's actually very easy to memorize this. It's the Pythagorean theorem, and then minus 2, repeat these letters, times a cosine of whatever the first letter was. So here we go. In this case, I'm going to write A squared equals 21 squared plus C squared, so plus 42 squared, minus 2 times B, which is 21, times C, which is 42, times the cosine of A. Don't use the sign. Sometimes students slip and they use the sign. This is the law of cosines, times the cosine of 39. And if you're really, 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 really good at mental math, you can do it in your head. Otherwise, use a calculator. Make sure you're in degree mode. All right, I'm getting 834.1. So this missing side must be 834.1. I'm kind of waiting for someone to nod no. Good. No, it's not 834.1. 834.1 is a squared. Now, I don't want no a squared. I want no a. So take the square root of both sides now. So the way I do it is I just go to the power of 0.5. 0.5 power is the square root. The 1/2 power is the square root. So I'm getting 28.8. So we're going to get that a equals 28.8 units. And that looks about right. I'm going to check it with the angles. Oh, I can't yet. I only know one angle. All right, I can't do that yet. Okay, so we have found the missing side. Now, because it says to solve the triangle, we would actually need to go ahead and find the angles as well. And you can use a lot of cosines to find the angles, but I don't recommend it. I would say if you want to find the angles, use a simpler formula. Which one looks simpler, the law of cosines or the law of sines? Which one's simpler? I mean, you've seen it now. This thing's a beast. This is forever. So what I would do now is I would switch gears and say, okay, I've used the law of cosines to find the missing side, but now I'm going to switch to the law of sines to find the missing angle. Now I need you to pay very close attention. Here is some advice, and I'm going to give you this advice in red. Find the acute angles first. When you're finding angles in a triangle, I would advise you to find the acute angles first. Now, we're going to go through this exercise, and you're going to see why I'm advising you to find the acute angles first. So I want everyone to join me now, and we are going to not follow that advice, and instead, we're going to find the obtuse angle first. So we're going to find angle C. Are you ready? Let's go for angle C. So we're going to say that the sine of C over 42 equals the sine of 39 over 28.8. All right, that should be nothing weird to you. You should be like, yeah, okay, I get that. Go ahead, find C. Once you have C at home, somebody let me know what you get, please. Okay, so Delaney, you have the ratio there of 0.918. Now what is the sine of that, or the arc sine of that? Okay, I think that's it. You guys in class, anybody have an answer for this yet?
I got 66.2.
66.2 is what they're telling me in class. 66.6 is what they're telling me at home. Any tiebreakers here? But it's 66 point something. What did you guys get? Anybody else? 66 point what? 6. All right, I'm going to go with that because it's 2-1. Now, I want you to look at this angle. Does it look like it's 66.6? Just looking at it. Now, don't trust the scale. You should never just trust the scale. But does it look like it's 66 degrees, or does it look like it's more than 90? Looks more than 90, doesn't it? Let's see what happens though. If I say that this is 66.6, so 66.6 plus this one here is 39, that makes 105, which would make this one over here 74. This would be 74. But look at it. Can this angle be 74, which would be the largest angle, and this side is 21, which is the shortest side? You can't have the largest angle match the shortest side. So this angle can't be 74, which means that this angle can't be 66. So we did something wrong. The angle's not 66. We did something wrong, but at the same time, we actually didn't do anything wrong. I mean, this proportion's right. So here is the issue. And listen very carefully to this, and I hope you understand this. The in-between step, which I'm going to steal from Ms. McCorkle there, was this, that the sine of C equals 0.918. Did y'all get that number there at some point? And then what you did is you found the inverse sine of 0.918, and that gave you the 66 degrees. However, visualize this on a unit circle. Here's my unit circle. 0.918. Where is 0.918? It's about here. And remember, the sine is the height. So this height is 0.918. So we got that the angle was this one, which was 66.6 degrees. However, is that the only place where the height or the y value is 0.918? No. There's another one there, isn't there? There's another one there. In fact, this angle would be its supplement, which is 123.4. And, right? No, 113.4. And that is the angle measure that we wanted. The angle measure is actually 113. So the measure is not that, it's 113.4 degrees. Now you're saying to me, well, how was I supposed to know that, Mr. Beretti? Here is the thing. When you are finding the sine, your calculator will always give you the answer or the angle in the first quadrant. It's not going to give you all the possibilities. There are an infinite number of possibilities on this unit circle, and you could go around, and it could be 426 degrees, and keep going around. It's just going to give you the first one. It is up to you to know from the context that you actually needed the second one in this particular case. You can avoid this problem if you do what I said when I gave you this advice. Find the acute angles first. So if there's an angle that is obviously acute, like angle B, find that first, and then use 5th grade math to find angle C. That'll save you the trouble. Anyways, so the angle has to be 113.4. And then angle B, well, that's a piece of cake at this point. It's 5th grade math. 27.6. Okay, so there is how you use the law of sines with one cautionary tale. We'll do one more example, and that's it for today. We're now going to use the law of cosines. Did I say sines? That's how you use the law of cosines to solve a triangle. We're going to use the law of cosines to do one more, but this time we're going to be finding a missing angle. So turn your paper over. And here he is. This guy is a side, side, side. You have zero information about its angles. You got to find all three angles. I'll just be specific. I'll remind you of one thing. When we did the law of cosines, these two were no's. You cannot use the law of cosines with those two situations, but you can use the law of cosines. You cannot use the law of sines, but you can use the law of cosines. So let's go for it. Because of the way I wrote the formula, I'm going to go ahead and find the measure of angle A, I guess. We'll do this one. All you got to do is just plug it in. So you try it. Oops. Give you guys 2 minutes to give it a go. I'm really hungry. You guys hungry?
Yeah.
This whole 1:30 thing is crazy. Actually, I have to take lunch at like 11. Yeah. And I guess subtract 85 from both sides. All right, I'm hoping you guys did this. So 64 equals 36 plus 49 minus 84 times the cosine of A, which gives you 64 equals 85 minus 84 times the cosine of A. Now at this point, it can be tempting to want to combine these two terms together. 85 minus 84 cosine of A could be like 1 times cosine of A, but you can't do that. These aren't like terms. That's like saying 85 minus 84x. You can't combine them. So I'm going to subtract 85 from both sides at this point. And when I subtract 85 from both sides, I get negative 21 on the left. Now I divide both sides by negative 84, and I get 0.25 equals the cosine of A. Now I'm going to go to my unit circle and visualize this before I even look it up. The cosine is the x direction, and so 0.25 is about here and there. So when I put this into my calculator is going to give me this angle right here. Just looking at a unit circle looks about 70 degrees, more or less. The calculator is not going to give you this one here, which is around 300. But that's another possible answer, but it's not going to give you 300. It'll give you like, what does it give you? What's that number there? Someone punch it in. What's the invert arc cosine of 0.25? You guys are so scared. we're starving. What is it? Fine, I'll do it. I'm getting no help here. Arc cosine of 0.25 is 75.5 degrees. And there you go. The other possibility was way down here, like 285 degrees, but your calculator is not going to give you that one. So there we go. That is how you can find one of the angles. Now, once you've found one of the angles, you can repeat that process for the other two angles if you are a glutton for punishment, or you can just make it a lot easier on yourself and do the law signs and then just 5th grade math. So I'm going to go ahead and finish it by using now the law signs to find angle B. That's what I'm going to do next, but you can do whichever one you want. So the sine of B over 6 equals the sine of 75.5 over 8. And that should be easy. So 6 and I'm getting 46.6 for this for B. I hope you guys all got that. The reason I chose to do B next because that was the one that was the smallest angle, so I knew it was going to be acute. And once you have that, the last one is just 5th grade math. So the measure of angle C is 180 minus 46.6 minus 75.5, and that's going to equal something. 57.9.
Great. I apologize.
Oh, fine.
I need to steal 3 students for just a few minutes.
Well, why don't you just steal about half of them then?
How about 1/5?
All right.
You're back. I'll take that. Ethan Diego, Eliana Cruz, and Summer. So just come on out for just a minute. Chat quickly. Okay.
Good. I don't know if it's good news or bad news when he comes by. If it's the principal, it's usually bad news. If the security is bad news. I don't know. Anyways, there it is. So just as a completion for the chart, for those of you who like charts, so we just did side, 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 in which obviously you couldn't use a lot of sines, but you could use a lot of cosines. Remember that this, with side, side angle, you can use either, but you could get 2 answers. With these other cases, you could use the law of sines, or not cosines, because law of cosines, you can't have 2 angles, obviously. And the only one that you can do with neither is angle, angle, angle. If all you know is 3 angles, it's obviously impossible to find the sides, because a triangle could be unique sides. So there you go. That is how you use the law of cosines. So in the next lesson, we're going to look at Heron's formula for finding the area of a triangle. And for now, that's it. So what I would encourage you now, if you're at home, you're done. I'm going to post an assignment in WebAssign in about an hour. I'm sorry I haven't posted it yet. And if you're in school, what I would encourage you to do is grab your quiz, and let's start taking a look at that quiz and make sure you can do that. Okay? So if you're at home, I'll see you later. Hopefully that's helped, and the assignment will be posted in about an hour. So go have yourself some lunch, and you come back in an hour. We'll be there if you want to do it. All right. Goodbye.